Hi everyone. I'm going to make a quick video on the desmos part of the 3.6, 3.7 examples. I'm hoping you've got that printout in front of you because the screen capture I'm using right now isn't smart enough to let me switch back and forth so that you can see the document. So the very first thing in there should be an example that has a whole data set with number of hours an astronaut spends weightless and their reaction time after that period. So all I've done so far is in that document, I've highlighted the table with the data in it, the entire thing. You can include the title or not, Desmos figures it out. Highlight that table, and then we want to copy. And then we're here at Desmos, so just desmos.com, D-E-S-M-O-S. And then we want to start graphing. So go ahead and hit that. And unless my computer's just slow, there's always a little lag there. Okay, and now I'm just going to paste it in. You can Control V or just hit paste. And ta-da, there's your data set. So just so that you know, the X's here are the hours spent weightless part. And you can even, I think, let's see, change the variable in here. And the right-hand column is the person's reaction time, which I gave a little t to. See if that'll cooperate with me. Okay, and I'm actually going to go over here and hit this graph settings button. If you see that in the top right, graph settings. And we can mess with this more, but you can also label here. So the x-axis is reaction, hours spent weightless. And then the y-axis is reaction time. And that is in seconds. Okay, so we can close that back down and notice that it has labeled on each axis what I just typed in. So you can drag this around. If you have a tablet, you can just grab and zoom in, zoom out. It's really quite handy and wonderful. I love it. Here, I'm going to zoom out a little bit more. And now we're looking at a data set. And here's the idea. For now, we don't really have many choices, but the idea is we'd want to, oops, sorry, apparently I'm still clicked on there. We'd want to look at that data set and ask ourselves if it appears to be linear. And we will have other choices. We'll have curves, so we'll have a parabola shape, and we'll keep adding shapes to that list. That's kind of part of our purpose in this class and in 141. So looking at this, it seems reasonable to say that I could draw a line that would do a decent job of representing that trend. And we did that in class, but the beauty of Desmos is you can just paste that right in, and then you can go ahead and have it do all the work for you, and it will find the best fit line. And in this case, it's doing linear regression. It's finding the least squares line. So its definition of best fit, if you're interested, you don't have to remember this, is that the sum of the squares of all the errors, basically distances from the point to the line, is minimized. So there's a square thing in there so that the plus minus don't cancel each other out, the points above and the point below, and then you just add up all those errors, and that is what the computer is trying to minimize when it fits this line. So there are other ways to do that, but that's a really common one. One thing to maybe keep in the back of your head about that is that it's really affected by outliers. So I don't see any big outliers here, but if you had one point way off on its own, that potentially could have a lot of influence on a least squares line. So just to be aware of, not anything that I'm going to ask you about. Okay, so let me see if I'm right in that this will... let me call these variables t and h. I don't know for sure that I'm right about that. So when you do this, you need to get t sub 1, and to get the sub, this is typed up in steps in problem number 2. You're going to do shift and then the underscore slash dash key. So underscore, you need an underscore, and that drops it down to a subscript. So I want t sub 1 to be an equation, a linear equation. Oh, and it needs to be a tilde, not an equal. M times H sub 1. And when you get down in that subscript, to get out of it, I just push over. I don't know, there might be other ways to do it. plus B, and it did. It let me use whatever variables I want. So the sub1 is just how it marks data. I don't know that we have a choice on that. Maybe you could go up in the data set and delete it. I always just stick with it. But otherwise, whatever your two columns are called in your table, that's what you're going to use down here. So the H's are basically our X's and the T's are our Y's. So we're using a Y equals MX plus B. The tilde tells it to fit a curve of that form. And then what it does is down here at the bottom, you can see it finds your M and your B for you. So right below where you type that in, it'll give you some information. So the equation for our best fit line is reaction time T is equal to roughly 0.13 times hours spent weightless plus roughly 0.16. And I'll flip back over after this video and we'll put that into the document. We'll look at it a little bit more. But I also want to talk while I have you here about the fit, and in particular this R squared value that shows up right underneath the line. I don't need you to know a ton of the details about linear regression, but that R squared value is a big one. R squared is going to give you some decent information about how good your fit is. So if you want like a direct way to interpret it, basically that R squared value tells you the percent of the variation in that data set we see, so the variation in our Y values, that is explained by our linear model. So 1 would be a perfect fit. If all your points fell exactly on the line, you'd get a 1. 100% of the variation is described by that model. A 0 would mean that there's absolutely no linear pattern, basically. The line doesn't explain it at all. And then you can have anything in between. So we're looking at roughly 90% of the variation is explained by this model. I'd say that sounded pretty darn good. So I don't have like specific cutoffs for you, but if you're in the 80s or 90s, let's say, that's a decent fit, especially in the 90s, you're getting a really good fit. If you're at like 50, 60%, I'm not very impressed by that. Even 70s kind of meh. So I think I have a decent fit. I have a decently good model. I'm going to feel fairly good about predictions that I make with this model. Let me think what else I want to say. Interpolation and extrapolation. I think that's my last thing. So when we use a model, there's two different words. So this is vocab. Please do remember these. Interpolating is when you use the model to give you a value that's within the, basically like the domain of the data set. So we have reaction times from 5 to 14. If we use the model to tell us what it thought was happening for any time between 5 and 14 hours spent weightless, we would be interpolating. If we go outside of that very much at all, we're then extrapolating. We're using it to figure out what's happening outside of the actual data set. So if we don't have a very good fit, we definitely don't feel good about doing much extrapolating. We maybe won't even feel that great about our interpolating, but definitely don't want to do much extrapolating if we don't have a nice solid fit. Okay, so that's the desmos part, and we will do this again for quadratic models, and all you have to do is change that basic format. We used an MX plus B, so for quadratic we just use a different form and it'll do that. At this point, you can either use a snipping tool to just kind of screenshot this chunk. If you're going to screenshot the whole thing, please crop it. I don't want all the extra stuff. Otherwise, you can go up to this little button at the top, Share Graph. And it's going to be slow. It's normally not this slow. This is special because I'm trying to make a video. There we go. Okay, so you have some choices here, but we want to export image. And sometimes when it does this, the numbers are too small, so you can actually adjust this and make the font bigger, basically, and it makes the lines and the dots better. The dots look terrible on thick, but medium can be nice. Again, from here, you could just snip this out if you want. Otherwise, if you hit download, it'll open it up in probably Microsoft Paint. That's what mine does. And then you can copy and paste it into your Word document, so you've got it there. Okay, so that's the technology piece, and then I'll make a separate video to answer a couple questions, which is pretty quick.